Dear friends, now we'll have a quick revision of circles of 10th maths. So here we are going to have a total mind map, or you can say the concept map of a chapter circles, and this will definitely help you in quick revision of this chapter circles. So here important formula, concept and theorems used will be discussed. So now let us see what is meant by circle. So circle is nothing but a collection of points in a plane which are at a constant distance from a fixed point called as center. So here you can see, so here I have a center. From this center you take any point on this, so it will be at a fixed distance. So this is called as a circle. So all the points that are on the circle are at equidistant from this center. So this is called as a circle. So next one is, we need to know what is tangent to a circle. Tangent is nothing but a line that intersects the circle at one point. So here you can see I have PQ and a circle here. So this line PQ intersects the circle at only one point at A, that is called as A. So this is called as, this PQ which intersects the circle at only one point is called as tangent. Suppose if the line that is drawn is intersecting the circle at any 2 points on the circle, then this line PQ is called as secant. So in this case you can see the line PQ is intersecting the circle at 2 points A and B, but whereas in this tangent it is only intersecting at a single point. So if it intersects at single point, then it is, that line PQ is called as tangent, and but if it intersects at two different points on the circle, then it is called as secant. I hope you understood the difference between tangent and secant. But here in this case, in the first case, you can see the line PQ is non-intersecting the circle. So it is not at all touching the circle. So it is a non-intersecting. So just to differentiate, here it is shown in 3 different cases. A line PQ where it is not intersecting the circle, but in the case of secant, the PQ is called as secant because it is intersecting the circle at 2 points, but whereas the line PQ here is just intersecting at a single point, which is called as tangent. So that means here you can see, so tangent, there is only one tangent at any point on the circle. So here at point A I can have only one tangent, you can't have more than one. So at any point that you are taking on the circle, we can have only one tangent. So but whereas in the case of secant, this tangent is nothing but, it is a special case of secant when two end points meet. So when two end points of the corresponding chord coincide. Suppose if A and B here, which are the line PQ is intersecting at point A and B, but if this point, if we move this line, so ultimately this A and B will coincide. So that's what it means here. So tangent is nothing but it is a special case of secant wherein the two end points of the line PQ, they meet at a single point. So they coincide, A and B. If they coincide, then in that case the secant becomes tangent. So that's what it means here. So I hope you understood what is tangent. Tangent is nothing but a line that intersects the circle at only one point, and we can have only one tangent at any point on the circle. So this tangent is nothing but a secant where the 2 points coincide of its chord is called as tangent. So you also need to know, there are some theorems here. There are 2 theorems that you need to know here in this chapter. So first theorem, what it says, so if I have a tangent here, tangent to point at point P, and if I draw a radius from P to the center of the circle, then this radius and a tangent are perpendicular to each other. They are perpendicular. So in the first theorem, what it says, the tangent at any point of a circle is perpendicular to the radius through that point of contact. So what it says, so radius drawn from a point P, and the tangent drawn at that point P, both are perpendicular. So that means here in this you can see here in this diagram, OP is perpendicular to YPX, that is the tangent. YPX is a tangent, OP is a radius, both are perpendicular. Then what the theorem 2 says, so before theorem 2 we shall see the number of tangents from a point on a circle. So I have a circle here, if I have a point P within the circle, then there will not be any tangent. So no tangent can be drawn from this point P if the point P is lying inside the circle. But if point P lies on the circle, then I can have only one tangent. And if that point P lies outside the circle, then I can have two tangents drawn from that point P. I hope you understood the three different cases here, and this concept is required. Suppose you may be asked in the objective questions or fill in the blanks how many tangents can be drawn under different conditions. So you please try to understand this. If point P lies inside the circle, then you cannot have any tangent, and if point P lies on the circle, then I can have only one tangent, and if this P is outside the circle, then I can have two tangents drawn. So in this case you can see, if since P is lying outside the circle, I can have T1 and T2, two tangents can be drawn. So understand this, which will help you in answering the 1 mark questions. Then the second theorem, what it says, if I have point P outside the circle, so the two tangents are drawn. So in this case you can see here, from point P to the circle, I have PQ and PR are the two tangents, and these two tangents are equal. So the length, that is PQ, is equal to PR. So that these two tangents PQ and PR are equal. So the lengths of the tangents drawn from an external point to a circle are equal. That's what the theorem 2 says. So I hope these are the various points that you are required to know in this chapter, circles. Thank you friends, all the best. It will help you, definitely it will help you in last moment revision of the chapter circles here. So I have various videos on the various chapters are made. You please go through. Before that, you please subscribe, such that you can get all the revision of all the chapters of the 10th maths of both state and Cbse board. So thank you, please subscribe.